Okay, so today we're going to talk about constructing a confidence interval for proportion. We're just going to do the math part of it. So we're just going to construct the interval itself. We're not going to do the whole process. Tomorrow we will talk about the entire process and we'll do a few problems together. This section is about confidence intervals for proportion. The next section is confidence intervals for mean. We will only focus on proportion and mean. Why do you think that we focus on those two?
Unbiased.
They're unbiased, yes. Okay, next thing, you all need the formula sheets. The blue cardstock I gave you. How many of you completely lost yours and do not have it? You don't have this at all?
No.
Okay, not at all.
At home.
At home. I'm going to give you a plastic one.
Okay.
Braden, you have one at home or not at all?
I don't know.
We'll go with not at all. Okay, everyone else has one?
Plastic one. It's at home.
Yeah.
At home.
Yeah. Home.
Home. Home. Home.
You might have one. And take it back. Can I have one?
You are not you. That was for Marco. That was for Victoria. That was for you. Okay, you will be using this most of this semester. So if you do not have one, hopefully I just gave you a new one. If you have it at home, make sure you go get it. If you can't find one, there's 2 extras up here. If those are gone, print one out at home. Okay, so we're going to read the problem first, and then we're going to go to the formula sheet. Students in an AP Stats class want to estimate the proportion of students at their school that own a graphing calculator. To do this, they surveyed a random sample of 102 students. Overall, 57 of the 102 students they surveyed own a graphing calculator. Construct and interpret a 95% confidence interval for the true proportion of all students at the school that own a graphing calculator. I'm sorry. Okay, so here's what we're looking for. We are looking for the true proportion of all students in the school that own a graphing calculator. That's P. So we want to estimate a population proportion. That's why we use a confidence interval. So we use a confidence interval because we don't have the true population parameter. Now, this is when I want us to go to the formula sheet. We will be starting on this 3rd page. So this is a page you guys haven't used before. It says Inferential Statistics. So inference is something we talked about when you take a sample and you make a conclusion about the population. Here's the confidence interval formula. We wrote it down yesterday. Statistic plus or minus critical value times standard deviation. So I want us to write that down, and then we're going to figure out what all of those mean. So statistic plus or minus critical value times standard deviation of the statistic. Okay, we need to figure out symbolically, though, what this means. If we are estimating population proportion, what statistic will we be using? P hat, sample proportion. So this is going to be P hat plus or minus. Critical value is a number you're going to have to calculate. For proportion, it's always Z. And then standard deviation of the statistic. This is also on the formula sheet. Let's see if we can figure it out. Do you think you're going to use sample mean? Here it says standard deviation of the statistic. Are you going to use sample mean, sample proportion, difference in means, or difference in proportions? Sample proportion, right? Now, what do you notice, though, about this formula? Did you say it's big?
Yeah.
Shockingly not what I was looking for.
It has P in it. We don't know P.
Oh my gosh, yes, thank you. Do you notice that we don't know P?
Yeah.
Right? Isn't that the whole point of doing the confidence intervals? We don't actually know P?
Yeah.
Okay, so you need to be careful and not copy this as is. Because we're not going to use P, we're going to use P hat. So it'll be the square root of P hat, 1 minus P hat, all over N. So this will always be the formula for proportion. Okay, so let's fill it in now. What is P hat? So what is the sample proportion in the problem? 57 out of 102. So 57 students out of 102 had a graphing calculator. Plus or minus. We're not going to do Z just yet. I'm going to show you in a minute how to find Z. And then we have the square root of 57 out of 102 times 1 minus 57 out of 102, all out of 102. Okay, Z is based on this 95%. Now, Z is the symbol for a standard normal curve. So here's what that 95% means. That you're going to have some interval in which 95% of the data falls. This is the Z. Now remember from the symmetry of the curve that those are going to be the same, one's positive, one's negative. So we need one of those two. Do you remember how to find either of those? Jackie?
Isn't it 2 standard deviations?
It's about 2. So I want the exact number. Follow up, yes? You would use inverse norm.
Use 5% divided by 2.
Correct. So inverse norm is when you have a probability and you're looking for a z-score. Like Jackie said, if this is 95%, those two are 5% together. So that's why she said 5% divided by 2. So that's going to be 0.025. So then on a calculator, you're going to go second distribution, inverse norm of 0.025. Okay, you're always going to use the positive answer though. So you don't want to keep this negative answer, make it positive instead. It's okay if you round, so we're going to use 1.96. So that's what'll go in for your Z. Okay, you have 2 calculations to do here, the upper bound of the interval and the lower bound of the interval. I'm going to show you the way that I think is easiest to do this. So you're going to type in everything exactly as it looks. Bless you. 57 divided by 102. I always do the lower bound first, so I'm going to subtract 1.96 times the square root 57 divided by 102 times 1 minus 57 divided by 102, all divided by 102. So that is the lower bound for the interval, 0.462. Okay, please do not retype all of that. You don't have to. What can I do instead to find the upper bound?
Change the subtraction sign to plus.
Correct. On my calculator, I can do second entry. I think you all have something similar if you have a newer calculator. And you just go and change the subtraction to addition. So that then is your confidence interval. Yes?
So this is like the main confidence levels we use are like 95, 90, and 85 or 80 or whatever.
Mm-hmm.
Instead of like doing inverse norm, like why don't we just memorize like the
You're welcome to do that if you want to. Eventually though, in the next section we're not going to be using Z, we're going to be using T. And T has many more values. So you probably will end up memorizing the ones for proportion because you're going to use them a lot, but eventually you will have to use a calculator. Okay, the way you finish these problems is by interpreting. So take a minute, interpret both the confidence interval and the confidence level. Okay, I know you didn't have enough time, but we're going to move on. I'm 95% confident that the population proportion of students at this school who own a graphing calculator is between 0.462 and 0.655. 95% confidence means in the long run, in repeated samplings of size 102, approximately 95% of intervals constructed in this manner will contain the true population proportion of students that own a graphing calculator. Okay, if I asked you a follow-up question and I said, is there evidence that the majority of students, in other words, over 50%, own a calculator, what would you say? No, why not?
Part of the interval is below 50.
Right, and so it's possible that less than half own a calculator, graphing calculator. Good? Questions before we go on? Okay, you are not just allowed to do this whenever you want. There are a set of assumptions that have to be met in order to carry out this process. So that's what we're going to talk about next. There are 3 assumptions that need to be met. We're going to talk about what the assumptions are and then also why you have to check them. First assumption that has to be checked for every single confidence interval, no matter what kind it is that you have a random sample. Why do you think it's important that you have a random sample? Victoria?
It helps limit bias.
Sure. What else? I'm looking for a different word. Grace?
Is that you have to have a random sample on its population?
Correct. So the whole point of confidence intervals, you take a sample and you want to make a conclusion about the population. You're only allowed to generalize when you have a random sample. So random sample means that we can generalize to the whole population. So that's the first assumption. Second assumption, you have to have a large sample. Now, this is not something you're going to use your own personal judgment for. For a sample to be large, n times p hat has to be at least 10. And then n times 1 minus p hat also has to be at least 10. Now, you have seen those inequalities before. When? Victoria?
Is that when we're testing for normal?
For what to be normal?
For a normal curve, like a distribution?
What kind of distribution? You're right. Well, okay, yes, it does go back to sampling. Binomial, but it's because of sampling. So this shows that the sampling distribution is approximately normal. That's important because we're using z in the formula. Last one is what I call the 10% rule. 10% rule is that your sample size has to be less than 10% of the population size. That you have also seen before. Remember? Okay, when did you see it? What is its importance? Victoria?
Is that like for the certain formulas for standard deviation, you need to have the 10% rule, or else like you can't use it?
Very good. So the standard deviation, the p hat times 1 minus p hat, all over n. Do you all remember that this requires that you sample with replacement? No, that doesn't sound familiar at all. So you have to be sampling with replacement, but then we said that's not realistic at all. So if you have a small sample relative to the population, then sampling with and without replacement are pretty much the same. Okay, a few other things. What is the difference between standard deviation of a statistic and the standard error? Standard deviation is that square root of p times 1 minus p all over n. But then we talked about we don't actually have p, so the standard error is the p hat 1 minus p hat all over n. Standard error is an estimate of the standard deviation. Okay, so what is the formula for standard error? I just wrote it down. So you don't have to write it down again if you don't want to, but I'm going to. Is it on the formula sheet? I'm going to say yes/no. So it's kind of on the formula sheet. This one's on the formula sheet, but you have to know that the standard error is p hat and not p. Okay, how do you interpret this value? This value is an estimate of how far the sample statistic will vary from the population parameter. Okay, a few other things I want you to know. You need to be very careful with this terminology, standard error. So that is the standard error. Do not confuse that with this. What is that called when I include the z?
Margin.
Yes, this is called the margin of error. So please do not confuse margin of error and standard error. Okay, a few other things. I managed to skip a question up here. What do you think happens if one of those three conditions is not met? Can you still construct the interval?
No.
No. Now, I've never seen this happen, but theoretically, if you got a question that said construct a confidence interval and one of the conditions was not met, you still need to construct the interval because that's what the question says. And then in your conclusion, you would say this interval is based on the assumption that whatever assumption was met. With me? Okay, a few other things. One other thing. There is a way to do this on the calculator. I'm not going to show you just yet. Besides that, I want to give you a snapshot of what we were doing tomorrow. Do you want to see what it looks like to do the whole problem? Ready?
What?
So that's the first problem you're going to do tomorrow.